What if I told you that the greatest construction projects in human history were carried out without a single motorized crane or computer? Modern highways require repairs just a few years after the asphalt is laid, while Roman roads still serve as the foundation for European highways 2 millennia later. We are used to thinking that technology means speed, but ancient engineers built colossal structures in timeframes that seem fantastic even to today's construction corporations. The Romans did not just build buildings, they created a giant machine for processing stone, wood, and human labor into eternity. The secret of their speed lay not in magic or the help of aliens, but in a unique system of organization, logistics, and discipline. Every stone in the Colosseum or aqueduct took its place at a precisely designated time, obeying a single, flawless rhythm. The empire understood that the speed of construction was not a matter of comfort, but a matter of survival and domination in the conquered territories. Watch the video to the end to find out how Roman engineers made concrete set directly in seawater and why their methods still cannot be replicated by modern architects. Want to know a secret that will change your perception of people management? A Roman construction site resembled not a chaotic gathering of workers, but a giant, perfectly tuned clockwork mechanism. There was no room for improvisation or long meetings, as each participant in the process knew their maneuver down to the minute. Thousands of people moved as one, performing simple but strictly regulated operations. The lack of sophisticated technology was compensated for by the flawless coordination of human flows, where one group replaced another without pauses or downtime. The secret of the incredible speed lay in the division of labor, which had been perfected long before the advent of industrial conveyor belts. Skilled engineers did not waste time carrying heavy loads, and unskilled workers did not engage in complex measurements. Each team specialized in a narrow field of work, whether it was mixing mortar, cutting stone, or laying beams. This allowed each movement to become automatic, eliminating errors and unnecessary actions. Skills were passed on within specialized guilds, ensuring consistently high quality of workmanship. Planning began long before the first shovel hit the ground and was carried out with mathematical precision. Surveyors and architects marked out the territory, taking into account the characteristics of the landscape and the availability of resources. Supply logistics were calculated so that materials arrived at the site exactly when they were needed. Warehouses were never empty, but they were not overfilled either, so as not to interfere with the movement of workers. Each cart with stone had its own arrival schedule, strictly coordinated with the pace of wall laying. The organization of labor resembled a military operation where orders were not discussed but carried out instantly. Supervisors monitored not only discipline, but also the pace of work, setting the rhythm for the entire construction site. Signals from trumpets or flags coordinated the actions of hundreds of people over vast distances. When one team finished its work, the next was already standing by to continue the process. This continuity created the illusion that the walls were growing on their own. The Romans understood perfectly well that a tired worker works slowly and makes mistakes. Therefore, on large state construction sites, there was a shift system that allowed work to be carried out from dawn to dusk. People received strictly measured rations and time for rest, which maintained their physical strength. Caring for the workforce was not a manifestation of humanism, but a cold calculation by engineers. A well-fed and rested builder was as important a resource as a sharp tool or a strong rope. Large-scale projects required a huge amount of materials that had to be extracted and delivered. Quarries worked at the same frantic pace, cutting blocks of standard sizes. Standardization allowed the stone to be used immediately upon arrival without additional on-site fitting. This saved precious hours and days that would normally have been spent processing the material. The entire empire worked on construction, turning mountains into cities. The tools of Roman builders were simple but incredibly effective and reliable. They did not break as often as complex mechanisms and could be repaired on the spot. The use of levers, blocks, and pulleys allowed huge weights to be lifted with minimal effort. Engineers masterfully used the laws of physics, turning muscle power into creative energy. The genius lay in the simplicity of solutions that were accessible for mass application. The most important factor was the quality control system, which was implemented at every stage. The architect in charge personally checked the reliability of the foundations and the correctness of the geometry. Any deviation from the plan was severely punished, up to and including demolition and reconstruction at the expense of the guilty party. This forced the builders to work not only quickly, but also conscientiously. Fear of punishment and pride in the result went hand in hand. The speed of construction was also ensured by the widespread use of prefabricated elements. Columns, capitals, and decorative slabs were made in workshops in advance. The construction site was just like putting together a giant construction set. This allowed finishing work to be carried out in parallel with the erection of walls. The Romans valued time more than gold and knew how to save it. The result of this organization was structures that were built in a matter of months. What today seems like a miracle of logistics was everyday routine for Rome. The empire proved its greatness not with words but with stone laid quickly and permanently. This machine knew no fatigue, doubt, or pity. Do you think modern technology can completely replace such a harsh but effective human organization? Write about it in the comments. And don't forget to subscribe to the channel. Are you ready to learn the truth about the material that outlived the civilization of its creators? Roman concrete, or opus cementicum, was the revolutionary discovery that made it possible to build faster and on a larger scale than anyone before. Unlike the Greeks, who carved each block out of marble, the Romans poured walls, creating monolithic structures of any shape. This eliminated the need to perfectly fit the stones together. The liquid mass filled all the voids, turning into a single, indestructible mass. The main secret of this mixture was volcanic ash, pozzolan, mined in the vicinity of Vesuvius. Roman engineers noticed that when mixed with lime, this gray powder acquired amazing properties. It did not simply dry out, but entered into a chemical reaction, gaining strength over decades. The walls became stronger with each passing year, like a living organism. This allowed buildings to stand for centuries without major repairs. A distinctive feature of Roman concrete was its ability to harden even underwater. This opened up the possibility of constructing gigantic ports, piers, and bridges in record time. Wooden formwork was lowered directly into the sea and filled with a mixture that hardened in the salty environment. Modern concrete is destroyed by seawater, but Roman concrete only becomes stronger. This chemical miracle gave engineers complete freedom of action. Crushed stone, broken bricks, and ceramics were added to the concrete as fillers. This not only reduced production costs, but also solved the problem of construction waste disposal. Everything that was at hand was used, turning waste into building material. Lightweight porous stones were used for arches and domes to reduce the load on the walls. Heavy cobblestones were used in the foundation to provide a solid base. The process of pouring walls was simplified as much as possible and did not require highly skilled workers. Teams simply laid layers of stone and poured mortar over them, raising the formwork higher and higher. It resembled conveyor belt production, where the speed depended only on the delivery of materials. There was no need to spend time on the complex processing of each individual block. Buildings grew floor by floor with astonishing speed. The Romans also used concrete to create complex architectural forms that were not possible with masonry. Huge domes, arches, and vaults were cast over wooden frames. When the concrete hardened, the frame was removed, revealing a ceiling that seemed to float in the air. The Pantheon, with its gigantic dome, is the best proof of the capabilities of this technology. Engineers thought in terms of volume and space, not individual bricks. The concrete walls were faced with brick or marble, which gave them an aesthetic appearance and served as additional protection. From the outside, the building looked as if it were made of expensive stone, but inside it concealed a concrete core. This made it possible to save on expensive materials without losing any of the monumentality. The speed of the rough construction was complemented by the speed of finishing. The illusion of luxury was created by industrial methods. The strength of Roman concrete made it possible to build multi-story residential buildings, insulae, solving the problem of overpopulation. Rome grew upward, saving urban space and travel time. The low cost of the material made housing affordable, and the speed of construction allowed neighborhoods to be quickly rebuilt after fires. The city was constantly being renewed, shedding its old skin. Concrete became the lifeblood of urban architecture. This material made it possible to build grandiose baths, amphitheaters, and basilicas throughout the empire. Standard designs adapted for concrete were sent to the most remote provinces. Local builders could quickly erect a Roman building using local aggregates and imported pozzolan. Architectural expansion went hand in hand with military expansion. The Roman way of life was replicated in concrete. The mystery of the durability of Roman concrete has only recently been solved by scientists. The crystalline structures that form in it prevent the spread of cracks. Ancient builders intuitively found the formula for eternity, which we are trying to recreate. They built not for themselves, but for history. Do you think we should return to ancient building techniques, or are modern materials more reliable? In the next chapter, you will learn about a structure that defied the laws of physics. What I am about to show you was considered impossible before the arrival of the Romans. Aqueducts, these stone rivers floating above the ground, became a symbol of the victory of engineering over the landscape. To bring clean water to cities, builders had to cut a path through mountains and over deep gorges. The speed of their construction was astonishing because the city could not wait years for water. It was a race against time and nature itself. The main principle of the aqueduct was gravity, which required a perfectly calibrated slope. Engineers used special tools such as a horabat to measure the level with millimeter precision. The slope could be only a few centimeters per kilometer. An error in the calculations would mean that the water would simply stop or, conversely, break the gutter with its pressure. This mathematical precision was implemented in stone at a frightening speed. Construction was carried out simultaneously on several sections, which were then connected into a single network. Huge arcades grew in the valleys, allowing water to flow above the ground. The use of arch structures saved material and time, making the structure light and durable. The arch is an ingenious invention that allows large spans to be covered with little force. The assembly of scaffolding and hoops for the arches was perfected to the point of automatism. Tunnels for aqueducts were dug through rocks with opposing faces on both sides. Engineers calculated the meeting point with incredible precision so that the tunnels would coincide. Work was carried out around the clock by the light of oil lamps in dust and cramped conditions. The tunnelers dug into the rock, driven by orders and necessity. The speed of tunneling was a vital indicator. The waterproof concrete we mentioned was used to coat the inside of the gutters. This prevented leaks and ensured a smooth surface for the water to flow. Special additives made the coating perfectly watertight. Every drop of water extracted from the mountains had to reach the city. The Romans could not afford to lose resources along the way. Aqueducts often had several tiers, which allowed the gutter to be raised to a great height. The Gare Bridge in France is a magnificent example of such a three-tiered structure. Blocks weighing up to 6 tons were lifted to a height of 50 meters without cranes. The coordinated work of thousands of people replaced the power of hydraulics. The stones were laid dry, held in place only by their own weight and precise fitting. To speed up the work, standardized stone blocks were used, which had been prepared in advance. The quarries were located as close as possible to the aqueduct route. This reduced the delivery distance and accelerated the pace of construction of the supports. Logistics once again played a decisive role in this engineering triumph. The roads along the construction site were clogged with carts carrying materials. Cleaning tanks and sedimentation tanks were built parallel to the main canal. The water had to reach the city not only quickly, but also clean. A complex system of sluices and gates allowed the flow to be regulated and repairs to be carried out without interrupting the water supply. Engineers provided backup channels for continuous operation. The reliability of the system was built into the design stage. The arrival of water in the city was a celebration, but for engineers it was only the completion of another stage. Water-fed fountains, thermal baths, and private homes, demonstrating the power of civilization. The aqueduct was not just a pipe, but a political statement. Whoever controlled the water controlled the people. Hundreds of kilometers of aqueducts encircled the empire, creating a unified circulatory system. Many of them still stand today, reminding us of the grandeur of the project. The Romans proved that there are no barriers to human perseverance. Don't forget to like this video and subscribe to the channel so you don't miss new videos about ancient technologies. Guess how long it took to build this? The Roman legion was not just a military machine for killing, but also the most effective construction unit of antiquity. Every legionnaire was trained to wield a shovel and pickaxe as skillfully as a sword and pilum. On the march, the army could erect a fortified camp in just a few hours. It was a marvel of organization when a clear field was turned into a fortress before sunset. Each soldier carried not only weapons, but also construction tools: a saw, a basket for earth, and a pickaxe. The baggage train carried prefabricated elements of palisades and tents. Upon arrival at the site, each manipulus knew its area of work without additional orders. Earthen ramparts grew before our eyes. Moats deepened, and tents were lined up in neat rows. It was a choreography honed over years of practice. Road construction was also often the responsibility of legionnaires in peacetime or between battles. Soldiers paved the way for themselves and for future trade. The discipline and physical strength of thousands of men made it possible to cut roads through forests and swamps. The army did not wait for civilian contractors. It did everything itself. Labor was considered the best cure for idleness and rebellion. The legion's engineering corps consisted of highly skilled specialists, architects, surveyors, and carpenters. They supervised the work and designed bridges and siege weapons. Knowledge was passed on within the army, creating a closed ecosystem of technical expertise. The legion was a self-sufficient city that could build anything. The intelligence of the engineers was multiplied by the muscle of the soldiers. The bridges built by the legionnaires became legends of speed. Crossings over wide rivers were erected in a matter of days under the enemy's nose. The sound of axes and the screech of saws were harbingers of an inevitable attack. Wooden piles were driven into the ground with methodical cruelty. The speed of construction demoralized the enemy more than the sight of weapons. Military camps, which became the prototypes for many European cities, were built to a single standard. Straight streets, clear zoning, and sewage systems were all created in the field. A legionnaire transferred to the other end of the empire felt at home in the new camp. Standardization saved time on planning and orientation. Order was the foundation of the Roman world. The construction of fortifications such as Hadrian's Wall required the movement of millions of cubic meters of earth and stone. Legions stood on the border for years, turning the landscape into an impenetrable wall. It was hard, monotonous work, but it was done with relentless persistence. The stones laid by the soldiers marked the boundaries of civilization. The army also often extracted the materials itself. Legionnaires cut down forests, broke stones, and fired bricks. Many of the bricks found by archaeologists bear the legion's stamps. The army was the main producer and consumer of building resources in border areas. This reduced the cost to the treasury and kept the troops in good shape. Siege operations required the construction of giant embankments and ramps. During the siege of Masada, the Romans built a huge ramp to roll a battering ram up to the walls at the top of the cliff. This work took months, but it demonstrated the inevitability of Roman will. Legionnaires moved mountains to reach the enemy. Engineering was the weapon of siege. The Roman soldier was a universal tool of expansion. He conquered lands with his sword and secured them with his shovel. The roads, bridges, and cities built by the legions served the empire for centuries. Is the modern army capable of such large-scale construction between battles? In the next chapter, we will discuss the principle that allowed architecture to be replicated around the world. The Roman Empire was the first civilization to introduce mass standardization in construction. Engineers realized that uniqueness was the enemy of speed and opted for standardized designs. Bricks, pipes, beams, and columns were produced in uniform sizes throughout the empire. This allowed an architect in Rome to design a building for Britain, confident that local materials would be suitable. Construction became a matter of following instructions. The dimensions of the bricks were strictly regulated, which sped up the laying process. Bricklayers did not waste time selecting suitable pieces. They simply took the next one from the stack. This created even rows and predictable wall strength. Brick production was streamlined in huge factories. Millions of identical red rectangles were delivered to construction sites. Roof tiles also had a standard shape and size. This made it possible to quickly cover huge areas without worrying about fitting each element. Roofers worked at incredible speed, laying rows of ceramics like scales. If a tile broke, it was easily replaced with a new one from stock. Repairability was an important advantage of standardization. Even decorative elements, such as column capitals, were made according to templates. There were catalogs and samples that carvers and quarries used to prepare semi-finished products. These parts arrived at the construction site almost ready, requiring only final polishing. This saved sculptors from having to start their work from scratch at a height. Art became reproducible. The system of weights and measures was standardized throughout the empire. The Roman foot was the same in Africa and Gaul. This eliminated errors in the transmission of drawings and ordering of materials. Engineers spoke the same technical language, regardless of their origin. A single standard was the foundation of imperial logistics. Lead water pipes were cast in specific diameters. This made it easy to connect segments and calculate the capacity of aqueducts. Standard taps and valves simplified the maintenance of the city network. The plumbing of ancient Rome was surprisingly similar to modern construction kits. Standardization made complex systems reliable. Building layouts were also typical. Forms, basilicas, and baths were built according to similar, time-tested designs. Residents did not need to get used to new navigation. They intuitively understood the layout of any public building. Once builders had mastered one project, they could easily repeat it elsewhere. Experience was scaled instantly. Road milestones were also standard. They stood at equal intervals, informing travelers of the distance to the nearest city. This turned the road network into a predictable and understandable system. Information was organized in the same way as the stones of the pavement. Order in navigation reflected order in the state. Army tents and barracks had approved sizes, allowing a certain number of soldiers to be accommodated. The camp always occupied a predictable area, which simplified the choice of location. Commanders knew how much wood and leather would be needed to accommodate the legion. The logistics of war were based on the standards of peace. Standardization allowed Rome to build quickly, cheaply, and in large quantities. It erased the boundaries between provinces, creating a unified architectural space. What we now call globalization was introduced by the Romans 2,000 years ago with the help of a ruler and a plumb line. What if I showed you a time machine? Let's travel back to 55 BC to the banks of the wild and turbulent Rhine. Julius Caesar decided to demonstrate the power of Rome to the Germanic tribes by building a bridge where it was considered impossible. The task was not just an engineering one, but a political one, to show that there were no boundaries for Rome. The speed with which this bridge was built still amazes historians. In just 10 days, the legionnaires built a bridge about 400 meters long across the fast-flowing and deep river. It was a feat of organization and brute force. Trees were cut down in the surrounding thickets and immediately delivered to the shore. The soldiers worked around the clock, taking turns so that the river would not have time to wash away what they had started. It was a battle not with the enemy, but with the elements. Special floating piles were used to drive the piles into the riverbed. Heavy loads were lifted by ropes and dropped onto the logs, driving them into the ground. The sound of these piles echoed across the water, terrifying the Germans watching from the other bank. They had never seen anything like it. The technology suppressed any will to resist. The piles were driven at an angle against the current to increase the stability of the structure. A deck of logs and brushwood was laid on top and covered with earth. The bridge was wide enough for an army to cross in marching order. Cavalry, infantry, and wagons crossed to the enemy shore as if on dry land. It was a total show of force. A special design of the supports, known as icebreakers, protected the bridge from floating debris and logs. The engineers had anticipated all possible threats from the river. The current, which was supposed to destroy the bridge, flowed around its supports. Knowledge of hydrodynamics was combined with the practical experience of carpenters. Nature was conquered by calculation. After a short punitive expedition, Caesar returned and ordered the bridge to be dismantled. It was the final chord. We can build, cross, and destroy whenever we want. The bridge had served its purpose, and there was no need to preserve it. Destroying his own creation was the ultimate manifestation of power over matter. The speed of 10 days seems incredible even with modern technology. Imagine the project coordination, material delivery, and assembly. Today it would take months. Caesar had no bureaucracy, only a goal and a legion. The mobilization of resources was instantaneous and complete. This episode went down in history as an example of ideal military engineering. It showed that speed of construction can be a strategic weapon. The enemy, who expected the river to protect him for months, found himself defenseless against Roman speed. The surprise was ensured not by secrecy, but by the pace of work. The bridge over the Rhine became a symbol of the Roman approach to obstacles. If there is no road, they will build one. If a river stands in the way, they will cross it with a bridge. If a mountain stands in the way, they will pierce it with a tunnel. Engineering audacity was part of the national character. Do you think modern engineers could repeat Caesar's feat in 10 days with only hand tools? In the next chapter, we will learn how the world's most famous amphitheater was built. The Flavian Amphitheater, known to us as the Colosseum, was the pinnacle of Roman construction logistics. Building such a colossus in the center of a densely populated city was an incredibly difficult task. Not only did they have to build the walls, but they also had to organize the delivery of materials without disrupting life in Rome. Construction was in full swing day and night, turning the area into a bustling anthill. Hundreds of thousands of tons of travertine, tuff, and concrete were used for construction. The stone was quarried in Tivoli and delivered along a specially built road. The carts moved in a continuous stream, adhering to a strict schedule. Any delay could halt the work of thousands of people. Dispatchers regulated the movement of this stone conveyor belt. Giant lifting cranes, called trispastos, operated on the site itself, powered by the muscle power of people running inside huge wheels. These machines lifted multi-ton blocks to dizzying heights. The installation was precise, despite the enormous weights. Mechanics served architecture, allowing it to grow upward. The Colosseum was built in just 8 years, a record time for a project of this scale. This was made possible by a modular construction system. The arches and vaults were repeated hundreds of times, allowing the workers to gain experience and work automatically. The sections of the amphitheater were erected in parallel, closing into a perfect oval. Errors in geometry were unacceptable. Beneath the arena was a complex labyrinth of rooms for gladiators and animals, the hippodrome. The construction of this underground section required powerful waterproofing and a complex drainage system. Engineers drained the groundwater, creating dry and functional underground chambers. The technical features of the building were no less impressive than its facade. The system of entrances and exits was ingeniously designed. 80 arches allowed tens of thousands of spectators to fill and leave the amphitheater in a matter of minutes. Each arch had its own number, which has been preserved to this day. Crowd logistics were thought out at the design stage. Safety and comfort were built into the stone. Tens of thousands of slaves, including Jewish captives, participated in the construction, but professional builders were in charge. The skilled labor of masons and concrete workers was paid and valued. Slaves did the heavy, rough work, freeing the craftsmen for delicate operations. The combination of mass forced labor and high professionalism yielded results. Iron staples filled with lead were used to fasten the stone blocks together. This gave the structure elasticity and protected it from earthquakes. Tons of metal were hidden inside the walls, acting as a hidden skeleton. The Romans spared no expense on metal for the sake of strength. The velarium, a giant awning stretched over the arena to protect it from the sun, was a marvel of rigging. It was operated by specially trained sailors from the imperial fleet. Hundreds of ropes and blocks worked like the rigging of a giant ship. Engineering thinking also extended to textiles. The Colosseum became a symbol of the power of the Flavian dynasty and of Rome as a whole. It was built on the site of Nero's Golden Palace, returning the land to the people. This political gesture took the form of a grandiose construction project. The speed of construction was intended to erase the memory of the former tyrant. Roman roads were not just communication routes, they were the foundation of the empire, piercing the space. Road construction was carried out with maniacal persistence, regardless of the terrain. Engineers preferred straight lines, cutting through hills and filling in ravines. The road had to be the shortest route from point A to point B. Compromises with the landscape were minimal. The base of the road was a layered cake up to 1.5 meters deep. First, a trench was dug down to solid ground. Then a layer of large stones, statumen, was laid to provide a foundation. The road was built like a wall, only lying in the ground. Reliability was laid down from the very bottom. This was followed by a layer of crushed stone and gravel mixed with lime. Rudis. This provided drainage and shock absorption. Water did not remain under the surface, but drained away, preventing erosion. Roman roads always remained dry, which was critical for the movement of troops. Engineers fought against water at every stage. The third layer, nucleus, consisted of fine brick, rubble, and sand. It served as a cushion for the final covering. Each layer was carefully compacted, turning it into a monolith. The thorough preparation of the foundation guaranteed centuries of service. No potholes or ruts could appear on such a cushion. The top layer, the pavimentum, was laid out with large flat cobblestones fitted together. The surface was made convex so that rainwater would flow to the sides, where drainage ditches were dug. The road cleaned itself during rain. Mud did not stick to the smooth stone. Milestones were installed along the roads and post stations were built. It was a complete infrastructure with services for travelers. Fresh horses, lodging, a smithy. All this allowed couriers to cover huge distances at incredible speed. Information flew along the stone arteries. Tunnels and cornices were cut through the mountains. The famous Appian Way, the Queen of Roads, became the benchmark for road construction. It connected Rome with the south, opening the way to the east. Construction took decades, but each section was put into operation immediately. The road worked while it was being built. Roads were of strategic importance for the transfer of legions. The army could reach any point of rebellion faster than the rebels could gather. The stone under the soldiers' feet was the key to victory. The speed of march on a Roman road was the standard of mobility. The quality of the work was such that many roads are still in use today, paved over ancient stones. Roman engineers set a standard that modern road builders strive to achieve. They built for centuries without knowing the term warranty repair. Durability was a matter of honor. The network of roads that spanned Europe, Asia, and Africa became the material foundation of our civilization. It united peoples, cultures, and markets. We still walk in the footsteps of Roman sandals. The Romans did not simply fit their grandiose structures into the surrounding natural environment, striving to preserve harmony. They acted like conquerors, ruthlessly and permanently reshaping the landscape to suit their imperial needs. For them, mountains, rivers, and seas were merely materials to be subjugated to the will of man and the state. The extraction of resources, especially gold and silver for coinage, required methods of unprecedented industrial scale. In Spain, in a place called Las Medulas, imperial engineers used technology that was astonishing in its audacity and destructive power. This can safely be called the first environmental disaster of antiquity, the traces of which are still visible thousands of years later. The Romans called this terrifying method ruina montium, which translates as destruction of mountains. The name fully reflected the essence of the process, as the mountains were literally wiped off the face of the earth. The essence of this barbaric but ingenious method was to use the kinetic energy of water to collapse entire mountain slopes. The Romans realized that water could be explosive if the laws of hydraulics and pressure were used correctly. A complex network of narrow tunnels and blind shafts was dug into the bowels of the mountain, containing gold-bearing rock. Workers labored in the darkness, creating a veritable sieve inside the rock, ready for destruction. To implement this ambitious plan, infrastructure was required that was even more complex than the extraction process itself. Builders erected hundreds of kilometers of aqueducts and carved channels directly into the rocks to bring water to the surface. The water had to be delivered to the tops of mountains, which required precise calculations of the slope over enormous distances. The slightest error in the degree of inclination could render the entire system useless. The engineering preparation for a single explosion took many months of intense labor by thousands of people. The destruction itself lasted only a few moments, destroying the results of millions of years of geological processes. The Romans used the hydraulic power of water as the most powerful hammer in the world. Cold calculation and technical ingenuity overcame the natural hardness of stone. After the grand collapse, the painstaking washing of gold-bearing rock in long wooden sluices began. Water washed away clay and sand, carrying light, empty rock further downstream. The bottoms of these channels were lined with thorny branches from local shrubs, heather or rock rose. Their rigid structure was ideal for trapping heavy gold particles. Gold flakes and nuggets got stuck in the branches while the flow of dirty water carried away everything else. Then these branches, saturated with gold dust, were collected and burned over a slow fire. The resulting ashes were then easily smelted into the purest precious metal. It was a real, well-oiled conveyor belt for extracting wealth from the bowels of the earth. Gold flowed into Rome like a wide river, ensuring the power of the empire and the luxury of its elite. But the appetites of the Romans were not limited to mining minerals in the mountains. They also boldly drained huge lakes and swamps to obtain new arable land. The population was growing, and the empire needed more and more grain, which had nowhere to be grown. The famous drainage of Lake Fucino became one of the most ambitious engineering projects of antiquity. Emperor Claudius planned to drain the huge lake through a mountain to turn the bottom into fields. This required the construction of a drainage tunnel almost 6 kilometers long through solid rock. No one had ever attempted such a large-scale underground construction project before. Thousands of workers and slaves chopped away at the rock with pickaxes and chisels for 11 long years. They worked in inhuman conditions, in cramped quarters, with poor air quality and the constant threat of cave-ins. For ventilation, vertical shafts had to be dug from the surface of the mountain down to the tunnel. But in the end, perseverance prevailed, and the fertile land on the site of the lake fed Rome. Changing the natural course of rivers for irrigation or urban construction was also common practice. The Romans were not afraid to interfere with the hydrology of entire regions and change the landscape. They built massive stone dams and embankments that stood for centuries. This is how huge artificial reservoirs were created where nature had intended there to be dry land. In the Roman engineers' view, water was meant to serve man, not flow wherever it pleased. They confined rivers within stone banks and directed them where it was economically advantageous. It was a purely utilitarian approach, devoid of sentimentality towards wildlife. Efficiency and utility were placed above the natural beauty of the landscape. Large-scale terracing of steep mountain slopes allowed grapes and olives to be grown where previously there had been only bare rock. Workers built thousands of kilometers of retaining walls to keep the fertile soil from sliding away. The landscape was transformed into a giant green staircase of gardens, reaching up to the sky. This made it possible to use every meter of land in the mountainous regions of Italy and its provinces. Hard human labor transformed the wild and inhospitable terrain into a veritable agricultural paradise. Every piece of land was used with maximum efficiency, bringing income to the treasury and owners. Wine and oil produced on these terraces were distributed throughout the civilized world. Even today, many of Europe's vineyards are located on those very Roman terraces. Harbors and ports boldly cut into the open sea, protected by powerful artificial breakwaters. Ostia, the main sea gate of ancient Rome, was almost entirely a man-made creation of engineers. They poured concrete directly into the water, creating new shores and convenient moorings for ships carrying grain. Nature was forced to retreat before the onslaught of Roman engineering will and technology. The sea became simply an extension of the land, a convenient route for trade and troop movements. The scale of the transformations was such that traces of Roman activity are still clearly visible even from space. The cut mountains and straight lines of canals remained on the planet's surface forever. They left deep scars on the Earth's surface, which became eternal monuments to their power. The Romans took absolutely everything they wanted from nature, using brute force and sharp minds. They did not wait for favors from the surrounding world, but took the necessary resources by force. Their civilization was built on the foundation of conquered nature, rebuilt to suit human needs. It was a great lesson in what a person armed with knowledge and ambition is capable of. Roman cities were saturated with complex engineering infrastructure, hidden from view but vital to life. The sewer system, the great cloaca in Rome, was as much a wonder of the world as the temples. A huge underground channel lined with stone drained the marshy lowlands between the hills, making life in the city center possible. The Cloaca Maxima was so large that a hay cart could pass through it. It not only carried away sewage, but also coped with storm drains, saving the city from flooding. Regular maintenance and cleaning of the canals was a state task. Sanitation was the key to the survival of the metropolis. The hypocaust floor heating system allowed the Romans to live comfortably even in the cold provinces of Britain and Germany. Hot air from the furnace circulated under the floor and in the cavities of the walls, heating the stones. It was an efficient and environmentally friendly source of heat. Warm floors, which we consider modern, were the norm for Roman villas. Public toilets, or latrines, were connected to running water that washed away all waste. This was a high standard of hygiene for the ancient world. Marble seats and the sound of water made going to the toilet almost a social event. Engineers took care of the comfort of all citizens. Roman baths, or thermae, were veritable palaces of health. A complex system of boilers and pipes supplied water of different temperatures to huge pools. The engineering systems of the thermae occupied entire floors underground. Maintaining this machinery required an army of stokers and technicians. Fire safety was ensured by a network of hydrants and the presence of night guards. Vigils. Rome, which had survived the Great Fire, learned to fight fire systematically. Wide streets and stone construction were passive protection measures. The city learned from its tragedies. Grain warehouses, horea, were designed to stay cool and dry. Ventilation shafts and raised floors protected the grain from rotting and rodents. Food security was the foundation of the government's stability. Engineers stored the empire's bread. Street lighting, albeit primitive, existed in large cities. Oil lamps at the entrances to houses and shops dispelled the darkness. This reduced crime and prolonged the city's active life. Light was a symbol of civilization. Fountains in the streets provided free drinking water to every passerby. Excess water in the aqueducts was discharged into the street flushing system. The city washed itself using gravity. The abundance of water was the pride of the Romans. This entire infrastructure functioned for centuries, providing a standard of living that Europe was only able to return to in the 19th century. Roman engineers understood that the greatness of a city was not only about statues, but also about clean water, warmth, and dry streets. They built a machine for life. We have seen that the Roman miracle was not an accident, but the result of a strict system, ingenious engineering, and incredible human labor. They built faster than modern machines because their machine was people organized into an ideal structure. Their concrete is stronger than rock, and their roads lead us through the centuries. The Romans did not just build buildings, they built the future in which we live. Their legacy teaches us that ingenuity and discipline can overcome any obstacle. What other ancient technologies do you think are undeservedly forgotten today? Suggest topics for new videos in the comments, and be sure to subscribe to the channel so you don't miss the next journey into history.